This trip has been full of fascinating things. From day one, flying in on a twin otter, flying over really, really remote terrain, landing in the middle of it, being dropped off, watching that twin otter leave. It was really awesome.
Welcome to Kamestastin. We made it. Not even 24 hours late. So it's all good. On this expedition here at Kamestastin, we're conducting some research onto various aspects of understanding the impact cratering process. And we also have 4 astronauts along. 2 of the astronauts from the Artemis 2 crew and 2 other astronauts, both Canadian and US. We're here providing geology training in this unique site. We're bringing astronauts to the Kamestastin Lake impact structure here in northern Labrador for a few reasons. The first is that it's a well-preserved meteorite impact structure. There are relatively few of those on Earth, period. We also have a couple of other unique aspects. The first is that the target rocks that it formed in, part of that was anorthosite. Anorthosite is the pale white rock that most of the lunar crust is comprised. We also have some exceptionally preserved, what we call impactites. These are rocks produced from the impact. We have impact melt rocks, impact breccias, and you put all of those 3 factors together and it really does make Kamestastin unique in the world and the most perfect lunar analog.
Right now, we are on a geology field expedition to really just kind of scout for future trainings for the crews that are going to land on the moon. Myself, Christina, and Jeremy Hansen from the CSA are working together as crew members from Artemis 2 to sort of learn what we can to apply it to our own mission, taking everything we've learned so far in our training and helping to feed that back to the team so that when we do train the crews that are going to walk on the moon and do that field geology in situ on the moon, they have the best training possible.
This is our first station. I gave everybody some great maps about where we are regionally. Geology is not very good unless you can tie it to context, but this is a great place to know where you're at on the map.
Hiking around that we're doing here is definitely challenging. There are no trails here. Some of these places, even our trip leader hasn't been in over a decade. We are scouting this area, and that is really cool.
You can see
I jokingly say there are no books about what we're studying here, and we really are writing the book as we go.
something for everybody.
And the book that we're writing is about how we're going to train humans to go back to the moon.
One of the real benefits too of bringing students and myself coming to meteorite impact craters here on Earth is that we can go up to outcrops, we can collect samples from exact and known locations, and that's not something we have for the moon. Big cliffs that you see, kind of the right-hand edge in the shadow there is impact melt rock. It also gives us a really good view looking back into the crater, and you can hopefully appreciate a bit of the morphology of the impact crater too. We've found our first outcrop of impact melt rock. So one of the early observations and one of the things to record is, are we seeing a lot of clasts? Because kind of how we classify melt would be clast rich, clast poor, and that can actually help us figure out where in the stratigraphy we are. Because we generally see clasts at the base and at the very top and kind of going both ways we'll get fewer and fewer clasts. Ideal stuff for dating, this is awesome. 90% of this is impact melt. It was melted by the impact event and it recrystallized and reset your radiometric clock. There's only one or two other impact structures on Earth where we have even a tiny bit of an orthosite, and here at Mistastin we definitely have the most.
This whole hill is melt rock from the impact, and so I've been looking around in this wall trying to find a chunk that had an orthosite, which we know we expect to find on the moon in the melt rock. So this is a chunk. I'm going to save it, see if I find an even better one on my trip, but this will be the first one that I save to take home. So I've got melt rock from the impact, and I've got this target rock, which is fairly rare to find on Earth, this an orthosite, and now it's in melt rock. So it's kind of a cool little treasure.
As someone who's not a geologist with my background, I have to really talk these things out with people to understand them. Reading a book isn't going to do it, but if I see things in the field, it starts to build a picture that I can apply in the geology of the moon. Coming together at the end of the day, telling stories about the adventure that we just went through, hiking together for the day and talking about the geology, that's actually been the best part about it for me.
This is a piece of anorthosite that we picked up yesterday. This is a rock that is representative of the type of rocks you would see at the moon's surface. And what I'm going to do is I'm going to analyze it by this scientific instrument here that looks quite funky. It looks like it belongs out of the 1960s or 1970s sci-fi shows. But it's actually a scientific instrument, and it's going to tell me the geochemistry of this sample while we're in the field.
One of the best ways to learn geology, anything about geology, is really coming into the field. And so this really does make this an exceptional place to bring students so that they can better understand some of the samples that they've been looking at in the laboratory setting or things that they've seen in the book. And so, experiential learning in a field setting is one of the best things that we can do for our students.
And being able to look at the change in the melt rocks and being able to actually find samples, chip off samples, and all of us were coming together and comparing what we could see. It was a bunch of geologists doing exactly what we love. Looking at rock samples, trying to interpret what we were seeing, whether we were agreeing with each other or whether we could spot differences in the rocks that other people hadn't spotted before.
We really want to help prepare for the Artemis program, the exploration of the moon. But we're also here to do science that allows us to better understand impact cratering and how that will shape surface processes and create the features and rocks that we see on the moon. And so a lot of that comes from doing very high resolution surveys of the outcrops that are visible here and exposed at the surface, and trying to understand how the rocks are different and how they vary spatially around the impact structure. So that means taking really high resolution images and really high resolution elevation data. So that's what this drone here is for, and the LiDAR data that we're taking, which essentially is a series of thousands of lasers that point to the ground and give it XYZ information. Allows us to recreate this space in virtual reality for more robust training programs for Artemis in the future.
My master's thesis project is about taking images from satellites orbiting the moon and trying to use that in my geological training to sort of figure out what's going on in a particular crater on the moon. But it's so abstract, it's been really helpful to see this in person, and I want to do more. I'm feeling myself pulled by this experience toward like EVA training and analog missions and things like that.
It's not every day I get to go inside an impact crater, so it's a great experience because we don't have the physical rock samples with us at the university when I'm studying them. And also it's just been a great experience meeting the astronauts and the EVA team from NASA and just learning a lot from them also.
We have a group of 16 here, tons of chores to do all the time, meal prep. Fetching water from the lake, you name it, and there isn't a single chart telling everyone what to do, but we get it done because we all want to pitch in and we all want to make it happen. And that's actually the same spirit that I see on the space station.
Wow, that is bold.
Sometimes it's so enjoyable here with the people that you can almost forget that you're here to really get down and dirty on the geology. So I make sure to ask a lot of questions about the geology so that I can glean as much as possible, because I could easily just come out here like it's a camping trip with friends because everyone on our team is so great. But making sure that I have some real tangible takeaways for geology is important.
Kamestastin lake impact structure at the present day, 28 kilometers across. Tycho on the moon is just shy of 110 kilometers in diameter. If you account for 1/6 gravity though, basically the same energy would have produced the similar sized crater. We've lost a lot of the morphology of the crater rim, this terraced region, but we've clearly got the central uplift in the middle. And then the relatively flat crater floor, which in Tycho is all impact melt, but with kind of bits of bedrock poking through. You see these irregular big mounds. Those are, several hundred meters high. All of that pretty much at Mistastin is unfortunately underneath the lake. West Point that we will go by today is right on the periphery, kind of around here as we start to transition into the crater rim region. This is breccia, but it's got some melt in it. This is quite classed rich melt, so somewhere in this zone would be ideal. But again, in one kind of fist-sized sample, we'll never be able to get the full thing. So that's where the the imagery is going to be really important for this, and the before and after images of sampling. So that's another thing too. You might be whacking this trying to get this sample, you can't, and this piece falls off. So you might have taken the before picture here with a scale and things, but it's this piece you end up with. So making sure you've got before and after images is really critical.
To come out here and train with the people who are going to be the backbone of the Artemis program think is really important because you might have one perception of something from orbital imagery or satellite imagery, and that applies to both the Earth and the Moon. And it varies significantly when you actually get down on the ground and you see what's actually happening. And so that perspective shift is really informative because that is kind of the same shift we'd expect the astronauts to see from orbit versus from actually being on the ground and exploring craters on the Moon.
One of the things that we talked about trying to do from the start is to talk about how the things that we could observe from being in our position of going around the Moon, what can we give to the geologists? What is useful? And one of the things they told us is actually describing the color. And you would think that we have a million remote sensing instruments that have studied the Moon. How could we possibly need human eyes to tell us the color? But the truth is, that's exactly what we need, because those are the same eyes that have classified the rocks on the Earth for so long, ever since the geology was born.
Especially for the Moon, you know, this would be the ancient lunar crust. There's fragments. So in the one sample, right, we can not only date the impact basin, but the clasts are going to tell us about other part of lunar history as well. So that's a really nice example of that as well.
And you can tweak a remote instrument's calibration and it can tell you something is any color. But what you can't know is, does this look the same as what you saw on Earth? You know, we are seeing some of the same minerals, some of the same rocks. Anorthosite is the big one. That's the whole reason we're at this crater in particular. Understanding the difference between the anorthosite on the Moon that we will observe from above and what's here is something that I will feel more confident doing because I've seen what they do on the ground and what they need to know from us.
If you're trying to get involved in a program where you are on the forefront of exploration, then the most important thing is to build your list of contacts and your professional expertise.
Who you know is really important, and who you know can get you better opportunities, can get you the opportunities that will build towards experiences like this.
Get involved. Just reach out, talk to somebody, find a professor doing something you like, and email them. Because I was wondering about
My hope is that we've laid the foundation here with this expedition for future missions and expeditions. I hope that we'll see, a regular cadence of coming up here with astronauts to this unique site here in northern Labrador.
I want to make sure that when I walk away from this training, I could tell someone, around the table, tell my mom, tell my dad, tell my husband, this is what I learned and this is why it's important. And so I just have to really focus on that.
It's important for us to understand our planet, to understand the planets beyond, and the planetary bodies like the Moon and Artemis. In terms of the rocks, is going to be so important for us to really understand the Moon in more detail. I think it will revolutionize lunar geology as a whole. I can't wait to see what happens, and I can't wait to see the samples and see what we can find out.
For Jeremy and I, as crew members of Artemis 2, one of the things that actually is most important to us is that we enable the success of future crews. So we don't think our mission is truly done until the next crew does their mission, and that's one of the reasons why being here is so important. We're actually figuring out and helping to contribute to how we can make this training as good as it can possibly be for the crews that are going to land on the Moon.